Well, good evening, everyone. Yes, it is evening. So, a lot of people were gone today for the Writing 121 field trip, and so I thought I would work up. Well, it's one problem, but really has a lot of parts, so it's more like several problems. And hopefully, this problem will illustrate some of the work that is in section 6.3 in our textbook on differential equations. So, let's come up with a good scenario. So Tom Alvarez is driving down the road and he sees a raccoon in front of him in the middle of the road. Being a responsible driver, Tom is only traveling at a velocity of 80 feet per second, headed towards the raccoon. Being a responsible driver, Tom hits the brakes and brings the car to a stop in 5 seconds. Just short of the raccoon. So everything's okay. The raccoon is safe. And so my question for you is, if we assume that the acceleration, which in this case is really deceleration, but we'll just call it positive and negative acceleration for mathematical terms. Assuming that the acceleration is constant while the brakes are being applied, what is the acceleration of Tom's car? What kind of a car is this, Tom? This is a Toyota MR2. Great little car. This is a 91 Toyota MR2. Okay, so what is the acceleration? All right, well, we know that velocity equals the velocity, the initial velocity, in other words, what he was going before he hits the brake, plus acceleration times time. And we know that the v sub 0 was 80 feet per second before he hits the brakes. And we also know that acceleration equals 0 when the car stops. When Tom's MR2 stops. Okay, so, and we know that happens at t equals 5 seconds. So we can use all of this stuff to say that, let's bring this down, or copy it, I'll clone it, I'll copy it, whatever. Okay, so let's put all this stuff together that we know. So we can say that the velocity is 0 at 80 feet per second plus 5 seconds times a. Cool. And we can solve for a, because then we can say negative 80 feet per second equals 5 seconds times a. And then we can say a equals negative 16. Well, no, I think I'm gonna actually show this to do the dimensional analysis. A equals negative 80 feet per 1 second over 5 seconds really over 1. So A equals negative 80 feet per 1 second times the reciprocal here, 1 over 5 seconds. I don't know what units 1 would be, but anyway. A then equals negative 80 feet divided by 5 seconds squared, which is correct, 80 feet per second squared. And A equals negative 16 feet per 1 second squared. And I did this longhand because I want you to appreciate the units here. Okay? So there's our acceleration, or in this case, deceleration, negative acceleration. For Tom, hitting the brakes to avoid hitting the possum, and the possum, it's not possum, it's a raccoon, sorry. So we're going to say raccoon lives. And you're probably thinking, uh-oh, there'll be scenarios that are different. Okay? So let's try another one. How are we doing on time? We're 6 minutes into this. We can make it. Okay, so let's try another situation. How about how far does does Tom's MR2 travel from the time he hits the brakes to the point he stops. Okay? So, how far does Tom's car go from the time he hits the brakes until it stops? So we did the acceleration. Now we can do distance. Now, I hope you remember way back in the day, like a month ago, maybe it wasn't that long, feels like it, when we talked about if you have velocity with respect to time, and this is in feet per second, and on the x-axis, if you have time in seconds. Okay, remember, and if you have some kind of graph doing whatever, and we look at this as an area between that graph and the axis, then the height of this graph at any place is v of t, and the width of this rectangle is dt. And let's think about units. V of t is in feet per second, and then we multiply to find the area. Let's call it this red area here. We multiply to find this red area. The height is in feet per second. The width, dt, is in seconds. And so when we go feet per second times seconds, the seconds divide out, and we're left with distance in feet. With distance in feet. Maybe I can grab all this and move it over. Okay? So the area under the velocity curve, or the area between the velocity curve and the axis, is actually a distance in feet in this case. Okay? So when we say how far does Tom's MR2 travel in those 5 seconds, we can say, well, that's just the integral of velocity with respect to time. How cool is that? And how powerful. So the distance equals the integral from 0 to 5. Now remember, back in the first part, we said that v of t equals 80 minus 16t squared. This was really v sub 0 plus acceleration times time, and we got negative 16t squared for acceleration. So we can just take that and integrate it. 80 minus 16t dt. So 80 minus 16t represents velocity with respect to time. dt represents the width of this rectangle here. And then the integral from 0 to 5 will give us the distance while Tom was stopping. How cool is that? Okay, so that means d equals... Now let's think of this just a little bit differently. Let's think of this as the integral from 0 to 5 of 80 t to the 0 minus 16 t to the first dt. So that gives us d equals 80 t to the first over 1 minus 16 t squared over 2 evaluated from 0 to 5. So now we have d equals, I love these guys, 80 times 5 minus 16 times 5 squared. Oh, no, I don't need 16. I'm sorry, I didn't see that 8 there. It's really 8. 16 divided by 2. 8 times 5 squared. And then close that minus. And I know you all think this is silly, but I think it's important. 80 times 0 minus 8 times 0 squared. Just don't forget that. I know it's all 0, but just don't forget that it's there, because sometimes you'll have a different limit of integration to evaluate. So that gives us d equals 400 minus 200, and d equals 200 feet are our units that Tom traveled in order to stop before killing that poor innocent raccoon. Okay? So, the raccoon lives in 200 feet of stopping, but just barely. All right, item next. I'm going to do a new page because I think I might run out. So, what if Tom was late for a real big fish? Am I spelling real right, Tom? Or is it R-E-E-L? I'll just go with this. What a real big fish concert. And so Tom was traveling and foolishly driving the MR2 at 160 feet per second because he's late for the music. Tom, I fear, and I don't know because we'll do the math, but I fear that this is a bad decision. Okay, so he's late for the concert, he's in a hurry, he's going fast. Let's see what happens with his stopping distance. First, how long in seconds will it take to stop. Okay? Well, now v sub 0 equals 2 times 80 equals 160 feet per second. So v equals 160 minus 16t. This is the deceleration or negative acceleration caused by the braking action of the MR2. So clearly t equals 10 seconds. Twice as long to stop. Okay? So does that mean the distance will be twice as long? We shall see. The distance equals, once again, the integral from 0 to 10 of 160 minus 16t dt. So that distance equals 160t minus 8t squared, evaluated from 0 to 10. I'm going to go a little bit faster this time, equals 1,600 minus 800. The distance equals 800 feet. Okay, remember, versus 200 feet at half the speed or velocity. Okay, 200 feet before to stop, barely saving the raccoon. So, Tom, what does that mean in terms of the raccoon? I'm going to pause here for a second. No, maybe I didn't pause. I've been doing that the whole time. Oh, I apologize. I thought I hit pause. Okay, Tom, it means that the raccoon is dead. Okay? Ah, man, that is bad. Okay? But then, okay, Tom, being a high-tech guy, says, wait a minute, Mr. Jennings. I have on my MR2 has the super duper EBC red stuff ceramic brake pads. Stop 1p. Stop twice as fast, according to the ad. Tom says, I can go twice the velocity to the Real Big Fish concert because my EBC red stuff ceramic brake pads will stop twice as fast. Well, let's see if the raccoon still lives. Do you think it does? Well, that means if you stop twice as fast that the acceleration will be no longer negative 16, but it'll be negative 32, what do we have? I got to make sure, I want to make sure. Yeah, negative 16t. So we can say, instead of 10 seconds, were we 10 seconds up here? We were 10 seconds. So we can just take this and go, it'll be from 0 to 5. Okay? So it'll be distance Oh, phone's ringing. Now I got to stop. I'll be back. Okay, so now we are at distance equals interval integral over the interval from 0 to 5 of 160 which represents the MR2's velocity, minus 32t, which represents the negative acceleration, dt. And this will give us the distance traveled at twice the velocity that he should be driving, but with the better brakes, so twice the acceleration. And let's see what happens with distance. So the distance needed to stop at now with the great brakes is 160t minus 16t squared evaluated from 0 to 5. And that distance equals 800 minus 400. And that distance equals 400 feet. So, Tom, even with the good brakes in the MR2, if you drive your car at twice the velocity, uh, guess what happens to the poor raccoon? Think about it, okay? That is the end. So tomorrow's quiz is on section 6.3, differential equations. And I hope that this video is useful for you. Eat well, healthily, and get good sleep tonight so that your minds are sharp for the quiz tomorrow. That is all. Good night.